In our last class period, we met the 6 trigonometric functions sine, cosine, tangent, cotangent, secant, and cosecant. In this video, I'd like to do 2 examples and then introduce you to the quotient identities. For now, let's write down the definitions for all 6 of our trig functions. So we know that sine is the opposite over the hypotenuse. We know that cosine is the adjacent over the hypotenuse. And that tangent is the opposite over the adjacent. And of course, we know that, or we know how to remember that thinking about SOHCAHTOA. All right, now for our next 6, if I remember how they pair up as reciprocals, tangent and cotangent are reciprocals of each other. Cosine and secant are reciprocals of each other. Sine and cosecant are reciprocals of each other. I know I can just flip those fractions upside down. So cotangent must be the adjacent over the opposite. Secant must be the adjacent over the hypotenuse. And cosecant, the reciprocal of sine, must be the hypotenuse over the adjacent. The hypotenuse. All right. Now, let's use these definitions to find some exact values of some trigonometric functions. So find the exact value of all 6 trigonometric functions evaluated at theta. All right, well, let's say I had a right triangle ABC. And let's let this be the angle I'm worried about, theta. I'm going to tell you that this side is 6 units long and that this unit is 8 units long. We're asked to find the exact value of all 6 trigonometric functions evaluated at that angle. So our first job is to find the missing side, which here is the hypotenuse. I'm going to call that missing side C. And then we know that C squared is equal to 8 squared plus 6 squared. 64 plus 36 is 100. The square root of which is 10. So now I know my hypotenuse is a nice, happy whole number 10. All right, well, now we can write down the exact value of all 6 trig functions evaluated at theta. All right, sine of theta, the opposite over the hypotenuse, is 6/10. Well, we'd never leave that written like that. Let's reduce that fraction to 3/5. And after I have sine, I know I can flip it upside down and make it into a cosecant, the reciprocal. All right, cosine, the adjacent over the hypotenuse, would be 8/10. But again, we're going to reduce that fraction. And we're always going to reduce our fractions to make them easier in subsequent calculations and just to make them as nice as possible. And again, after I have cosine, I can write down its reciprocal, secant. And then finally, tangent would be the opposite over the adjacent, which is going to be 6/8, or better known as 3/4. All right, let's do one more example like this. Same instructions, find the exact value of all 6 trigonometric functions evaluated at the angle theta, but this time with this triangle. All right, so this time I have a side marked 5, the hypotenuse is 7, and I'm missing this side over here, which I'm going to call A just for the heck of it. All right, well, this time the hypotenuse, 7 units long, is 7 squared is 49, is equal to A squared plus that 5 squared. All right, take 25 away from both sides, and A squared has to be equal to 24. So A is the square root of 24. But we always want to reduce on the inside of that radical, and we can, so that's going to be 2 times the square root of 6. And here again, we can write down the exact value of all 6 trigonometric functions evaluated at that angle. All right, so we're looking at this angle down here. Sine is the opposite over the hypotenuse, so that is 2 root 6 over 7. And again, the moment I know a sine, I can write down a cosecant. Cosine, the adjacent over the hypotenuse, so 5 over 7. That's a nice pretty one. And then finally tangent, the opposite over the adjacent. All right, so we've used our definitions to find the exact values of trigonometric functions. The other thing I wanted to accomplish in this video was to introduce what are known as the the quotient identities. We've already talked about the reciprocal identities. And we can actually use them to see something that's going on in a relationship here. If I look at the definition of tangent as the opposite over the adjacent, well, I can see that sine involves the opposite side, cosine involves the adjacent side, and they're both being divided by the hypotenuse. So I can look at those relationships and deduce a neat relationship between sine, tangent, and cosine. So let's just imagine that I take sine of theta and I divide it by cosine of theta. Well, let's see. On top, I have opposite divided by hypotenuse. On the bottom of that fraction, I would have adjacent divided by hypotenuse. All right, well, I'm dividing two fractions. And so what I can do now is think about how to do that. I'm going to leave the top the same. I'm going to change the division sign into a multiplication. I'm going to take the reciprocal of the bottom. And I notice that the hypotenuse parts would cancel off, and I would just have the opposite over the adjacent. Well, opposite over adjacent is the same thing as tangent. So tangent theta is always the same thing as sine divided by cosine. All right, well, I'm going to say a few more things about that, but let's take a look down here first and think about sine divided by cosine. Take 3/5 and divide by 4/5. So let's just think about that over here for a minute. Well, if I think about that, when I flip the bottom, the 5s are going to cancel, and I'm going to get 3/4, which is the value of tangent. All right, that is known as a quotient identity. And there are going to be two of them. So tangent of theta is always equal to sine of the angle theta divided by cosine of theta. Well, if I think about taking a reciprocal there, reversing that, well, I'd end up, instead of opposite over adjacent the way we did, with adjacent over opposite, which tells me that cotangent of theta has to be cosine theta all over sine theta. All right. So anytime I have a sine and a cosine, I can always find a tangent using this quotient identity, and the same thing for cotangent. Now, one neat thing to observe here is in our last class period, we saw reciprocal identities. And we know that cosecant theta is 1 over sine theta. And secant theta is 1 over cosine theta. That means I can write all 6 trigonometric functions down in terms of the first two, sine and cosine. Tangent is a sine over a cosine. Cotangent is a cosine over sine. Cosecant is 1 over sine. And secant is 1 over cosine. All right, well, that's it for now.